and documentation too. It's cool. Hi, thanks for having me here. This is yet another talk about ICANN and IANA and now the public technical identifiers. I have to keep thinking about PTI change to the KSK in the root zone for DNSSEC. I've talked about this in the last couple of NANOGs. This is going to be, now we're actually in the process of doing this, and so I want to get an update for what's going on. So one thing we have here is I'm going to show you the key today. This is the first time we've talked about it publicly. It's been available publicly for a couple of days now. It was actually made a few months ago. I'm going to talk about the status of our project, where things are, what's going to come up in the future, and also try to talk about some particulars for operators to know what to do in reaction to this as is going to happen during the year. For those of you who aren't familiar with this, the root zone DNSSEC is a process by which we add security to the root zone DNS. We sign records so you can judge whether they're the true record or not when they come from the real source. The KSK, which is a key signing key, is a particular cryptographic key which is used to launch the tree of all keys in the system. The KSK signs a zone signing key, which signs the keys of the next level down, and so on. So we're changing the top level key out here, and it makes it unique because this key doesn't depend on any other ones. You have to have a copy if you're going to trust it. The history of this right now, we've had a root zone DNSSEC KSK in place operationally since about 2010. It's the only one we've used operationally out there. Excuse me. We call it KSK 2010. The new one that we just created and are putting in place this year will be KSK 2017 in the slides. And this change may impact some of the operators out there. And if you're running a DNSSEC in a recursive server, if you're validating answers out there, you are currently using a trust anchor somewhere. You're probably using KSK 2010. You may have to review your documentation, your configurations, or you may have to import the new key, depending on your level of checking that you choose to do. For the milestones right now, we created the key on October 27th of last year. We went to one of our data facilities, we created the key out there, we put it into 2 HSMs. We then carried it across the country and we inserted it into the other facility February 2nd, just last Thursday. That made the key qualified to be operational. It's now in all of our facilities. If anything happens that we can account for, we're ready to go. So this key now is operationally qualified for working, and that's why we're talking about it. It doesn't mean we're using the key right now. It's going to be coming. We're starting the publication of the key right now. It's available on our website. We have a file which has the trust anchors in there, and I'll talk about that in the talk. On July 11th is the first time that this key will show up in the DNS. It'll be introduced there for the first time, with not being relied upon, but it'll be in the DNS. On October 11th is the time we start using it for real. And that's the date that you have to, if you're doing DNSSEC, be prepared for that date. That's the day where we change things. And if you don't change along, things will probably break on your end. And follow that in 2018, we'll clean up the mess that we've created. So the new key, this slide, the next one actually have the contents of the key and some representation. The first thing is, if you look at key tags in DNSSEC, it's 20326 will be the new key tag out there. If you look at DNSSEC tools and you pull out the key tags, if it's not that, it's not the new key. It's something else you've gotten. Below this, I have what the key would look like if it was in a DS record. I'll caveat this with that there really isn't a DS record for the root zone, but I'm using this for the convention of looking at the contents of this. The bottom two lines there are the hash that you will see used by some tools out there. And this slide here has what the DNS key record would be. When you look at the DNS and after July 11th, you'll see this record somewhere in the zone, and this is the embodiment of the public key that you should be looking at. For the purposes right now, these are just visual guides. I actually went through the online web slides and made sure that they're not modified from what I submitted, so NANOG's okay here. These are the slides. This is what we uploaded as the keys out there, and you can use this as reference later on, and we'll talk about how to do that. So why are there two forms of the record? Why did I present two forms of the key? It's because as operators, when you use tools, the tools you use determine what data structure you want to have. There are some tools out there that like to have the DS record as the input to the system, some with the DNS key record out there. So we have both of them available here in the presentation. To go deeper into this, you have to consult your choice of tools documentation. It'll tell you which is the more appropriate one. So where are we in terms of the change? This is a sunny day scenario. We're changing in nice, calm water. Nothing bad going on there. One of the ways to do this is that we want to leverage the trust we have in the current KSK 2010 to learn 2017, and we have a recommended course of action to follow the automated updates of DNSSEC trust anchors rather. It's also known as RFC 5011 protocol. Now I'm mentioning this because you don't have to do it that way. We find it's probably the least attack surface out there to do this. It'd be the easiest, and it can be lights out operation, but many people don't choose to run things the same way. So we have all other ways of getting the keys, and we do this through bootstrapping trust in them. If there were emergency conditions out there, we probably would have to go to something that's more bootstrapping than leveraging trust from one or the other, but right now we can rest assured that the old KSK is still good, still secure. We're going to use it to go forward. Automated updates of DNSSEC trust anchors, if you aren't familiar with that, it uses the current trust anchors to learn the new ones. We put out new trust anchors out there, we sign it with the old trust anchors, and unless you hear otherwise, you can assume after some amount of time that this new trust anchor is a good one to have as a trust anchor. It allows for unattended DNSSEC validator operations out there. If you run a validation out there, or validating server out there rather, and you want to let it just configure itself, you can just turn on this automatic updates and it will continually learn the keys. The whole theory behind this is time. As time goes by, if no one complains about the new key, it's the key. If someone were to try to break the process up, we would say something. Someone would say something. You'd certainly hear in the news that this key change is not authorized, is not the right thing to do, and just disrupt learning this key. On a calendar, what we're going to do is we're going to start this process on July 11th. By August 11th, you should have the new key learned in your system. So if you're running a system and you look through the monitoring tools that you have, in August you should see the new key is trusted. If not, you've got about another 2 months to fix whatever needs to be fixed. And we'll get into that a little bit later. October 11th is a day in which we change which key we use, and we have to go, at that point we need to go forward. This slide is going to just say what I said in the previous. July 11th, we introduced the new key. August 11th, you should have been able to trust the key through the automated updates process. After that date, start making sure that you have the key somehow. Ask questions, look for information, get help on this if you need it. October 11th, the new key goes live, so by that time it has to be handled. What's favorable about automated updates? The automated updates feature, RC 5011, is built in to just about, it's built into most of the popular tools out there. If you're doing DNSSEC validation, you're probably using a tool that has this feature in there already. Nothing you can't handle if you're running the code. You don't have to follow the updates. I want to stress that again. We're not saying you have to do that or it's the only way to do that. Is the automated updates preferred? It's easier to use, but again, it's up to you. It's up to your call to decide how you do trust out there. You can just do the automated updates, or you can use it as part of learning the key in other ways. Now, if you're doing anything automatically, you probably don't have to do a whole lot, but I'll get into some of the tool-specific stuff coming up. If you're doing it manually, you can get this key a bunch of different ways. We have already today changed the file that's listed on top there. This lists the trust anchors in the DS format that I showed earlier. You can download that and do some processing of that. Via DNS, starting in July, you can pull it down from the DNS, but be careful that if you pull it from the DNS, make sure you're not being attacked at the same time. And that by trust, you can compare the copies. And there are other means out here. We're working with software distributors, OS distributors, to pass the key through the system out there. We've been talking with the DNS implementers for quite a while now. Compare the key with what you saw on the slides. I would write down what you see and write that instead of even downloading the slides maybe. You can also get the key from other places and just compare to make sure they're all the same. If you see the same key everywhere, you probably are using the right key. There's also been talk of trinkets out there, like other giveaways, but nothing has come up yet. I've seen a few T-shirts given out already, but not a mass mailing of them. There is a tool, a Python tool that's been developed by some of the people at ICANN and also at Cure. This is a GitHub repository. It's also going to be available through the IANA website. It's a Python tool. It's a very simply written tool. It pulls the keys down and it will write out for you the files showing the DS record format that I showed earlier and the DNS key record for use in your tools. What do you need to do as an operator? You need to be aware of whether or not DNSSEC is running. Some people may have inherited servers without knowing that. Know how you establish trust within your organization. Test and verify your applications and make sure that they're set up correctly. Inspect the configuration files. Sometimes people update software but not the configuration files, and that could be an issue. And if DNSSEC's validation is planned or being done in your system, have a plan to react to this role. These tools up here, this is a list of tools that we have been looking at as part of the role. If there's a tool up there you think I should have listed, let me know. That would be very helpful. These are tools that are available to do some DNSSEC validation. Bind is a little special to us. Bind's been around for a long time. It's got the longest history of DNSSEC. One of the cautions here is that if you set up Bind to do DNSSEC a long time ago, besides updating the Bind software, the Bind version 9.2, 9.3, 9.7, 9.8, 9.9, make sure your configuration file is also updated. There was an old option for trusted keys, and there's a new one called managed keys. Make sure you're using managed keys, and that's something you want to inspect for that in that case. Microsoft Server has documentation out there, a couple of tutorials that, even though they've been written quite a while ago, they still apply. And there are other tools out here, Unbound, PowerDNS, NotResolver, and DNS Mask, all have some documentation on their websites relating to the trust anchor management, which is the key element, so to speak, key element of all of this. What kind of problems might be out there? There are two things that we're keeping an eye on. One is fragmentation of packets. When we're rolling the keys, the responses from the root zone are going to get larger than we've had in the past, and so there's some concern about fragmentation, especially in IPv6. One thing to look for there is if you see validation failing for everything, maybe you didn't get the new root zone KSK. Do you see lots of retries for those queries out there? If, on the other hand, the problems you come up with are because you have the wrong trust anchor, you have to look at why you didn't learn the new trust anchor out there, check in logs for failures there. Typically, there'll be different kinds of failure scenarios. What are the steps of recovery? Stop the tickets is always the first recommendation. Temporarily disable DNSSEC if you have to. People hate it when I recommend that, but things are what they are. Stop the tickets from coming in. Debug, find out what the root cause was. Was it because of 5011 not working? Was it because of network fragmentation issues? And then finally, test the recovery before you go forward again to make sure that you've got the key. If nothing else, if all else fails, you can bootstrap from the start again, making sure you have the right key and put it in there and configure and go forward. Educational informational resources we have out there. We have a bunch of documents putting out there right now. The ICANN website has a link that's given at that URL. That's kind of long to write down, and of course you can download the slides. But if you go to the ICANN's main webpage, there's an area called Quick Links, and you go down, there's Key Rollover is one of our quick links. It'll have copies of everything we present out there. It should have this presentation. I have to make sure it gets out there. We have the script that's mentioned, and we have information about some live test beds that we are working on. We are now finalizing some live test beds out there. Currently, there have been test beds out there to let us test RFC 5011 for developers of code. And that meant by changing some of the operational parameters, some of the code parameters rather, you could follow this in a much quicker way to see if the software worked correctly. These test beds are meant to be used by a production server on test zones out there. So you take a regular recursive server out there, don't play with any of the parameters that are undocumented, features that are available out there, and run it against these zones and see if these zones are able to be tracked for when they go through their rollovers. This will be available in a couple of weeks, I guess, before we have this done. You can run this in some of your test beds to see, is 5011 working in your system? It's going to mimic as much as it can what the root zone is doing, the size, and other issues should be encountered, the fragmentation issues out there. So, I thought I was going to be quick. I was quick. This is the basic summary slide of information out here. Let you know we have the key. The key is what you saw on a couple slides earlier. And if there, I would welcome any questions now and any concerns you might have about the process. I'll go back to the key so that everyone here can write this whole key down while you're waiting. We got 10 extra minutes or so. I hope the font's big enough for you. But this is what the key will be out there. I have liberties taken with presentation because if I were to escape properly, there would be backslashes all over the place and line continuation and whatnot. So. Questions? I guess not. Well, thanks for your attention.